Hi, this is Raphael Mudge, the creator of Cobalt Strike. Welcome to part 6 of Red Team Operations with Cobalt Strike, post-exploitation. In this lecture, I'm going to start out with beacon management material. I will explain how the agent is organized and how to do basic things with the beacon payload. We will then go into some special post-exploitation topics. For example, we will talk about session passing. We will talk about the different ways to execute programs within your beacon, because a program could be something on the target, it could be PowerShell, it could be .NET, and there are different options for all of these. We will also talk about the file browser and how to exfiltrate data from a target. And we will talk about user exploitation, taking screenshots, logging keystrokes, and other things as well. Finally, once I've introduced you to how to use the beacon agent, we will talk quite a bit about post-exploitation tradecraft. Let's talk about beacon management. Right-click on a beacon, go to Interact, and this will open the beacon console. This is where you type your commands, and this is where output and other messages from Cobalt Strike show up. If you right-click on a beacon session, or if you right-click inside of a beacon console, you will get the beacon management menu. Here is how it is organized. Access are options to manipulate your identity and privileges. Explore are tools to control the target or gather data from it. Pivoting are tools to tunnel data and tools through your beacon payload. And session are options to manage this particular access. When you use the beacon console, type help to get a list of commands, and if you want help for a specific command, type help and the command name. One thing to note, beacon is an asynchronous payload. When you type a command, that generates a task that gets added to a queue for that particular session. When that payload checks in or calls home, it will download all of those tasks at one time and execute them in the order it received them. After it does this, it goes to sleep. And going to sleep means the agent does nothing. It just sits there on the system waiting. You can change this sleep time. Use sleep and a number, which is the number of seconds that beacon should sleep for between processing tasks. You can also introduce a jitter factor. That is the second number. For example, sleep 60-50 will have beacon sleep for 60 seconds with 50% jitter. So that means the range of time that that beacon will call home will be between 30 and 60 seconds. There are a lot of commands built into beacon that map directly to Windows APIs to do things. These do not run a program. They do not go outside of the agent. They execute entirely within the context of the agent. For example, to change the context of how different programs are run, you have cd, pwd, and set-env to set environment variables, print the working directory, or change the current folder. To work with the file system, you have cp to copy files, drives to list drives, ls to list files, makedir, mv for move, and rm for remove. You also have download and upload. For process management, you have kill to kill a process, ps to list processes. And to query the registry, you have regquery and regqueryv. I do want to share some beacon console tips. Use Control-D to close the current console or other active tab in Cobalt Strike. Control-K will clear the console screen. Use Control-F to open up a find tool that will allow you to search the currently active console. you may need to click inside of the console to make it active. Control F works for tables too. And if you make a mistake when you type a beacon command and you want to undo it, use the clear command. This will clear all the commands in the beacon task queue and allow you to try things again. Let's take a look at some beacon management. Here we are in Kali Linux, and this session phoned home to us 25 seconds ago. The default sleep time is set in the profile, and by default it is 60 seconds. Please allow me a moment to change that to something else for this demo. So I'm going to right click, go to Session, Sleep, and we're going to make the sleep time 5 seconds. And if we right click, Interact, you can see how that GUI action translated to a command in the beacon console. Doing things via the GUI or the console are okay. It's definitely a personal preference. But now you can see our beacon is checking in every 5 seconds. Perfect. We are in a PowerShell.exe context, PID 5940, 32-bit. We are the user Jim Stevens, IP address 10.10.10.191, and we are egressing through the local HTTP beacon listener. So that is a little bit about our context, and the computer name is WS1. Perfect. All right, let's take a look at doing some things. So when we right click on a session, you can see we have the beacon management menu. Here are the access options, the explore options to interrogate the target, pivoting options to tunnel through the session, and session management options as well. For example, we can change the note to be something like foothold, and all of our teammates will see this. We can also assign a color to the session, such as green or pink, and all of our teammates will see this as well. You'll notice how I'm changing the colors, how it shows in the tab as well. And this is kind of a cool tool to label your sessions for whatever reason you may choose to do so. We'll just use the white color to make it neutral again. So that's a little bit of basic management. If you type help, you get a list of commands, and you can type help and a specific command to get more information on it. And there are a lot of things we can do in Beacon that map directly to the Windows API. For example, if we do pwd, this will print our current working folder. If we do cd, we can change our current working folder to somewhere else. So we're just changing directory over to C users Jim Stevens desktop, pwd. And there you can see we are in C users Jim Stevens desktop. Let's do an ls to list files. Nothing too exciting, but hey, why not? Let's talk about session passing. Session passing is using one existing session to run another payload. There are a few ways to do session passing in Cobalt Strike. You can simply spawn a temporary process and inject the payload into it. If you right-click on a beacon and go to spawn, or use the spawn command, that is what it will do. You can also spawn a session in a temporary process with an alternate parent process. That is what the spawn u command does. You also have the option to inject into a specific process. One thing I want to note, if you are going to work with multiple team servers, make sure that you name your listeners in a way that you can easily distinguish them between servers. You may say, okay, cool. Why does all this matter to me? Well, session passing is a very important thing to know how to do and to know your options for. This is what you will do when you want to pass a session from a long haul server to a post-exploitation server, and This is also what you will do when you want to migrate your beacon session to a safer process context. And this is what you will do if you want to pass a session to your friend who is still kicking it with the Metasploit framework. And while we're on the subject of spawning processes and injecting things, I should explain fork and run. Fork and run is a very common convention in the beacon payload. Here's our beacon payload. And when it wants to do something, such as take a screenshot or spawn a new payload, it will run a temporary process and it will inject the capability into it. Beacon is a memory injected DLL. So are Cobalt Strike's other features and tools. For example, if we were to inject a screenshot tool, we would get back our output over a name pipe, and then this temporary process would go away. But if we inject a beacon payload, the temporary process will stay and house the beacon payload. That is fork and run. Before you spawn anything, we absolutely have to talk about this subject right now. We can't avoid it. When you spawn a new process, be aware that not all process trees are treated the same by different endpoint security products and analysts. Some process trees are very risky to you. Things that will buy your process credibility. If the program you are running in has a valid digital signature from a trusted entity, that can help you. A plausible or safe parent process can help you here as well. It is very important that you are not in a process context that is normally associated with offense activity. You do not want to operate from an unsafe context. This can lead to your agent being found much faster, possibly by an automated solution or a human analyst. You also do not want to spawn a payload or a post-exploitation job to an unsafe context. For a similar reason, if you spawn to an unsafe context, your activity may get detected by an automated solution or a human analyst much, much faster. So how do you avoid an unsafe context when you spawn temporary processes? Well, welcome to session prepping. Session prepping is the concept of configuring your current beacon session to have safe temporary processes. Here is how you session prep. Use the PS command or the process browser to survey processes on the target. It may help, it may not, depending on the endpoint security products in play, to anchor your child process to an other parent process. You can do that with the ppid command. This changes the parent process of nearly all child processes run by that beacon session. Use the spawn2 command to change the program Cobalt Strike will run for its temporary processes. You can configure a spawn2 value for 32-bit and 64-bit programs separately. If you do not use the spawn2 command, Cobalt Strike will use the value that is in your profile. The default value in the default Cobalt Strike profile is Rundle32. I promise you do not want that. You absolutely want to have a better spawn2 value. Another thing you can potentially use if you are on Windows 10 or later is block DLL start, and this will enable DLL blocking. That's not really the subject of where we're at right now, but we will talk about block DLL start later on and the caveats of it when we talk about tradecraft. Now let's take a look at session passing and session prepping. Right away, you should notice that we are in a PowerShell.exe context. That is not a safe context for post-exploitation. Even if what we're doing is relatively benign, we may be vulnerable to a point-in-time analysis that is looking for signs of a memory-injected DLL in this process context. We do not want to live here. So let's get out of this particular process. Let's right-click, Explore, Process List, and let's get a lay of the land and see what's happening on this target system. Here you can see that we are in PowerShell.exe, which is a child of a 64-bit PowerShell.exe, which is a child of Explorer.exe. Now we could inject into another process. In fact, that's what we're going to do. Let's go ahead and jump over to process 5392, the Java Update Scheduler, and let's inject our payload there. So we'll highlight that, press Inject, choose our listener, hit Choose, and if all goes well, we will get back a new beacon session that lives inside of Java Update Scheduler. And you'll note that it has the default 60-second sleep time. We will address that. But let's go ahead and clean up and get rid of this session. So we'll right-click, Session, Exit, and when Beacon acknowledges that it exits, you will see that the little monitor here will fade. And here you can see the same thing in the console. The exit command and Beacon acknowledging the exit. To get rid of this stale session, right-click, Session, Remove. It is now gone. All right, let's get rid of these tabs and let's change the sleep time here to 5 seconds, which I think is workable for this demo. And when it checks in, it will pull that task, and we are now beaconing back every 5 seconds. Great. Now let's take a look at passing a session to another Cobalt Strike server. Let's go right-click, Explore, Process List. And again, we're doing this to get a lay of the land. And you'll recall that I said we should do session prepping before we start launching processes. So that's what we're going to do now. And we have a couple interesting options here. We could session prep. We're living in Java Update Scheduler, right? Well, we could actually make our child processes run as Java Update Check. And that could be a pretty plausible reason to have child processes off of Java Update Scheduler. Or we could use this Internet Explorer instance and spawn child tabs as children of this process 1012. Let's start out with Internet Explorer and make it our parent process. So we'll do set as ppid for process 1012 here. And that is going to issue a ppid command to our beacon console. And now any programs that are run through this beacon session will have Internet Explorer as their parent. And we are going to use Internet Explorer 32-bit as a temporary process for 32-bit post-exploitation jobs. So let's do spawn 2, x86, and I think it's C program files, x86, Internet Explorer, iExplorer.exe. So now we've changed our spawn 2 value and our ppid, and now we're good to try to pass a session to another team server. Let's connect to that server. Cobalt Strike, new connection. Let's go to secure.losenolove.com, press connect. And here we are. We are now connected to secure.losenolove.com. If we go to Cobalt Strike listeners, you will see that we have our listener named EC2 Secure HTTP. And again, that is to be descriptive of which server the listener is tied to and how it's configured. Now let's come over to our other team server, right-click Spawn, and you'll notice that we can see the egress listeners for all of our team servers. That's what happens when you connect to multiple servers. So let's choose that secure HTTP listener, hit choose, and when our beacon checks in, you will see that it is downloading that payload. And let's jump over to the other server. And here you can see we have a beacon living in iexplore.exe PID 5064. Right-click, explore, process list. And when that populates, if we go all the way to the bottom here, you can see that we are a child of Internet Explorer. We look like a child tab. So that is an example of session passing and session prepping. Now let's take a look at a foreign listener, which is a way to pass a session to the Metasploit framework. Let's come over here to a terminal, and we will start up the Metasploit framework console. Give that a minute. And let's do use exploit multi-handler. And this is just a generic exploit to host a payload handler. And let's do Windows Meterpreter reverse HTTPS. Note that I am using a 32-bit payload. Cobalt Strike's foreign listeners expect they are passing a session to a 32-bit handler. Set lhost, set lport, and let's set exit on session to false so that we can keep passing sessions if we choose to do so. And let's do exploit-j to run this in the background. And there we go. We now have our reverse HTTP handler. Great. Let's come over to Cobalt Strike and let's not maximize this. Let's see what's going on in Metasploit. Now let's right-click, spawn, and we need a foreign listener. Let's press add. We'll do foreign HTTPS, and we will call it local meterp HTTPS. And let's give it our IP address because Metasploit is running on the same system. Hit save, hit choose, and when our beacon checks in, you can see we get Meterpreter session 1 opened, right? Now let's come over here. Let's sessions-i1 to interact with Meterpreter. Do a get PID. You can see Meterpreter is in process 6644. Come over to Cobalt Strike. Let's come over to our process browser, hit refresh, and there we go. We now have 6644 hosting our Internet Explorer tab for Meterpreter. And so that is a foreign listener. With session prepping out of the way, I feel a lot better talking about executing programs. To run a program and get output, just do run, program name, and any arguments you want. This will run the program and arguments you specify. If you want that program to run from the context of another folder, use the cd command. And to see the current working directory for Beacon, use pwd. One thing I do want to point out while we're here, Beacon's command parser is position based. So when you do run and give it a bunch of stuff, the command and arguments you provide are passed to the Windows API to execute a program as is. They are not transformed. Same thing when you do cd. When you do cd to go to another folder, the path you provide is passed to the Windows API to change the current working directory as is. So if there's a space or special characters in the path or your command and arguments, don't worry about quoting or escaping because Beacon's parser doesn't require that. In fact, it will not know what you're doing when you do that. You can use PowerShell through Beacon. Back in 2014, this was some pretty cool, novel stuff. If you want to run a PowerShell commandlet, just do PowerShell, commandlet, and arguments. If you want to get help for a PowerShell commandlet, just do get help commandlet-full, and that will return the documentation baked into the comments of the commandlet. And if you happen to have a really cool post-exploitation capability written in PowerShell, you can import that for Beacon to use. Just do PowerShell-import and provide the path to the PowerShell script on your Cobalt Strike client system. And that capability, those commandlets, will become available when you use the PowerShell command, PowerPick, or psinject. PowerShell import does not touch disk, but there are OPSEC implications to it, and we will talk about those at the end of the tradecraft section. So be aware of that. One other note is that PowerShell does use PowerShell.exe. Here are some other ways to execute programs through Beacon. Let's say you've got an awesome capability written in .NET. You can run a .NET assembly through Beacon without touching disk. Use execute assembly. You can do execute assembly, the path to the file locally, and your arguments. One thing to note is execute assembly is an example of fork and run. Cobalt Strike will spawn a temporary process, that spawn2 value, inject code, a DLL, to run the .NET Common Language runtime, and have it ingest your executable and execute it with the specified arguments. You can use the shell command to run a command in arguments via command.exe. You can also use PowerShell without PowerShell.exe. That is the PowerPick command. PowerPick is another example of fork and run. Like execute assembly, Cobalt Strike's Beacon will run a temporary process, inject a DLL that loads the .NET Common Language runtime, and runs an assembly that will set up the PowerShell DLL and pass your commandlet and arguments to it. psinject is a variant of PowerPick, but you can target a remote process with psinject. Let's take a look at some other post-exploitation things such as running commands. I'm going to do one other bit of session prepping. Earlier, you'll recall that I set Internet Explorer as our parent process and made iExplore.exe as our spawn2 value. That's great. What I want to do now is use Java Update Scheduler, where we live, as the parent, and I think Java Update Check.exe would be a perfect pretext for a child process. So let's do a couple things. First, let's come over here and let's go to our Beacon console. I'm going to press Control-K to clear the screen. And let's go ahead and set this up. First, we're just going to do ppid by itself to reset the parent process. So now we are our own parent process. Next, let's go ahead and change the spawn2 value to be Java Update Check.exe. We need to find it. Let's do this. We'll do shell dir whack s whack b c:/. That's something called a dir walk. And we're going to pipe that to find string to look for Java Update Check. Now you'll notice we are using shell. We are using shell here because it lets us do an expression where we are piping commands to each other, or piping output from one command to another. And so it's convenient because we're talking about running programs here, right? So, all right, cool. We found Java Update Check. Perfect. Let's do spawn2, x86. And now our temporary jobs will run in the context of Java update check. So that's just changing things around a little bit. Now, let's try out a few things. Let's go ahead and try out the run command. The run command will just run a program that we specify and give us back the output. So let's go ahead and run the ARP command just to look at the ARP table. When beacon checks in, we will get back the output of the ARP command. Great. And I should note that that ARP command will be a child of Java Update Scheduler. And you may be saying, well, what about Java Update Check? Well, we're not doing anything related to temporary processes here. We're just running the ARP command. So there's no temporary process that's part of this. But let's do something that would live in a temporary process. Let's run the execute assembly command. Because the mechanism to run a .NET program in memory does use a temporary process. And we're going to use something from the GhostPack compiled binaries repository. We're going to run a program called Seatbelt. And Seatbelt will run in the context of Java Update Check, which is a child of Java Update Scheduler. And we're just going to do seatbelt.exe all. And you may notice when I ran execute assembly that I was able to tab complete the path to seatbelt.exe locally. You can tab complete a lot of things in Beacon. You can tab complete listeners, local paths, and sometimes different argument options to different commands. And you can certainly tab complete your commands as well. So you can see I'm tab completing arguments to help. So definitely take advantage of that. It will save you a lot of time. So if we look at the output of Seatbelt, we can see it gives us a lot of information about the current system. Recently run commands, any kind of Internet Explorer history. What's cool about Seatbelt is this is a good way to look for opportunities to harvest credential material, interesting files, and other things you may find useful before you start doing any post-exploitation. So this is a good survey tool to run. We can also run PowerShell and use that to run commandlets like PowerShell.exe, 2+2, or we could do PowerPick. PowerPick is PowerShell without PowerShell.exe. And you will see we get back our 4. One tool to interact with the file system in Cobalt Strike is the file browser. Right-click on a beacon, go to Explore, Browse Files. You will get back a tab that looks like this one. A few things to know. Initially, the tab will be empty. It will not populate until the beacon checks in and sends information back. The left side of this tab is a tree that shows what your current file browser knows about the target's file system. A folder that is grayed out means that folder is known to exist, but the contents of that folder is not known to the file browser. So if you click on one of those gray folders, Cobalt Strike will ask Beacon to get the contents of that folder and populate the file browser next time it checks in. And the folders that are yellow and have color are cached. So you can actually navigate this file browser in between beacon check-ins by just working with the cache. The right side is the actual file browser itself. The top is the address bar. It's where in the file system you are. The folder next to it will actually take you up a folder if you want to do that. And same thing in this right-hand side. You can double-click on a grayed folder to ask the file browser to request more information via beacon. And through this file browser, you can list drives, you can upload files, make a directory, you can right-click on a file and delete it if you need to. And you can even put a share into the address bar and navigate shares with this tool as well. Here are the basic commands in Beacon to download a file and work with downloads. Use download and a path to a file to download it. You can, of course, right-click and download in the file browser too, just fine. If you want to see the progress of your downloads, type downloads and Beacon will show you where each file is at in terms of downloading, because the download is sent back one chunk at a time each time the Beacon checks in. And the sleep time of your Beacon is very much going to affect the pace at which files are downloaded. If you want to cancel a download, use the cancel command, and you can use a wildcard here as well. When a file download is complete, go to View Downloads, and you can see all downloaded files that are on your team server. And to bring those back to your Cobalt Strike instance, highlight one or more of them and press Sync Files. To upload a file, use the Upload command. Just upload the local path to the file, and Cobalt Strike will push that over to the target. If you want to change the timestamps of the file to make it blend in with something else on the target, use the timestamp command. Timestamp will update the MAC values for the file, so modified, accessed, and created. And you do not need special privileges to do this. You just need write permission for the file. Let's take a look at the file browser. Let's go right-click on our Beacon, Explore, File Browser. And here is the file browser. You'll note when Beacon checked in, the file browser populated. If we click on Users here in the tree, when Beacon checks in, the Users folder will populate, and there's our Jim Stevens. Go to Desktop, Documents, Downloads. You can see how they all become populated once our Beacon checks in. And so in this way, you can kind of navigate through the file system. Or you can use this little folder here to go up a folder. That works just fine. So that is a little bit of the file browser. And if you want to download something via the file browser, you can just highlight what you want to download and press Download. And that will task Beacon, if we right-click Interact, to start downloading those files. And you can see that AccessCheck64 and AccessCheck.exe are downloaded. Now let's try List Drives. Press that button, and we will see the drives on the system. Let's go to the D drive, or we can just double-click it here. And when Beacon checks in, we will see that this must be the Microsoft Office setup disk. Let's see what's on it. Setup 32, setup 64, stuff in a data folder, very exciting. Let's download these, right-click, download. And what I want to show you is that we started downloading these larger files. If I do downloads, you will see that we are getting these files back 512 kilobytes at a time per check-in. So each check-in, we will get back another chunk of these files. Same thing. The last thing I want to show you is we can navigate a share on the file browser. So we'll do File Server, Acme, and when Beacon checks in, you will see a file server shows up in our tree. We can go to the Acme folder, Human Resources, Resources, Sys-Internal Suite, and when Beacon checks in with the information, it will populate our file browser. And we can download the salary data, we can download that background JPEG, and we could get more of the Sys-Internal Suite if we really wanted to. Now you may ask, how do I view these downloaded files? We can go to View, Downloads, and all the files that we have finished downloading will show up here. And to bring those files over to our local system, just highlight them, press Sync Files, and we will be able to choose a folder to dump those files to. And there we go. Those files have been synced to our local system in the demo folder. Beacon tasks, this includes long-running commands and post-exploitation tools that live inside of a temporary process or remote process run as jobs. A job executes in the background in between beacon check-ins. To see the jobs in your beacon, type jobs. To stop a job, use job kill and the job ID to ask beacon to terminate that job. To take a screenshot in beacon, use the screenshot tool. You can target a remote process or type screenshot by itself, and beacon will spawn a temporary process and inject the screenshot tool into it. It is the same story for the keystroke logger. Type keylogger by itself and beacon will run it in a temporary process or target it to a specific remote process. So earlier we did session prep so that all of our post-exploitation jobs will go into Java Update Check, which will be a child of Java Update Scheduler, with one caveat: our post-exploitation jobs that are 32-bit. We did not configure a spawn2 value for 64-bit post-exploitation jobs. We can certainly do that, but one thing to note is when you are using a 32-bit beacon, beacon will prefer 32-bit post-exploitation jobs, and when you're in a 64-bit beacon, it will prefer 64-bit post-exploitation jobs. So we should be okay for what we're going to do now. Let's go ahead and run the keystroke logger. If we run the keylogger, press enter, we can see the keylogger has been tasked. And if we type jobs, we'll wait for the beacon to check in. We can see that the keystroke logger is running as job ID 8. Perfect. If we refresh over here, we should see another Java update check. That's our keystroke logger. Now, let's inject the screenshot tool somewhere. The screenshot tool does have the ability to run for a long period of time, but if you're going to take advantage of that, you have to target it to a specific process. So we'll target it to Java Update Check in PID 1608. So let's press screenshot, have that run for a long time, and we should now be getting back screenshots and keystrokes, right? Right. Let's go to View, Screenshots, and here is where our screenshots will show up. If we right-click, make that a little bit bigger, we can see what is happening on our target. If we go to View, Keystrokes, we can see what is happening on our target via the keystroke logger. And nobody's typed anything yet, but I'm going to try typing some things now, and hopefully we will get some output back. And you can see that I am indeed typing something. You can see I typed I am a little teapot. So that is the keystroke logger. And if we look at the screenshot tool, we can see I am a little teapot being typed right now. Now let's say we want to watch both of these at the same time. Well, you can right click on this X and pop this out into its own window, or send it to the bottom of Cobalt Strike. In fact, I'm going to do Control B for bottom to send the keystroke tab to the bottom of Cobalt Strike. And now I can see both the screenshots and keystrokes as they come in. And let me jump over to my Windows 10 target for just a moment and start doing stuff. And you can see in the screenshot tool that I'm in my browser now, and I am trying to log into my webmail. And if you look at the keystroke logger, you can see that that context is there. You can see me logging in and typing in my password. And you can see in the screenshot tool all this different stuff I'm doing, such as composing a message. For example, I am now writing a message to Raphael Mudge stating that I am demoing something. Actually, I'll just send that message. Why not? So that is an example of the screenshot tool and the keystroke logger. And of course, as you change windows, the context in the keystroke logger will change as well and show you where it's grabbing keystrokes from. So that is those user exploitation features. One last thing to show you. If we come to our beacon console, type jobs, we can see that we will see, excuse me, we can see our keystroke logger and screenshot tool are running. We can stop these with job kill 8 and job kill 9, and now we are no longer taking screenshots or logging keystrokes. One little piece of tradecraft advice. Years ago, I used to recommend that you inject into explorer.exe to log keystrokes or take screenshots. Don't do that anymore. That is a dangerous context for offense activity. But when you log keystrokes and take screenshots, you absolutely need to do so from a process context that can see what is happening on that desktop session. So for example, if we were to live in a process up here in desktop session 0, and we tried to log keystrokes or take screenshots from up here, it would not work because from desktop session 0, we can't see what's happening in desktop session 1. And that's one of the reasons you can target a specific process with the keylogger and screenshot tool, is so that you can do user exploitation without migrating your access. Another user exploitation tool is Cobalt Strike's desktop command. This will let you watch or control the target's desktop. You can point this at a specific remote process or use desktop by itself to spawn a temporary process and inject into it. This feature does require that your beacon is checking in interactively. That means calling home multiple times a second. Use the sleep 0 command to make beacon check in interactively. One cool thing about this feature, there is a quality option. If you use the low quality option, Cobalt Strike will degrade the number of colors used, and it will change the JPEG encoding to something much more lossy and much better for bandwidth constrained C2 channels. Here is the desktop viewer in Cobalt Strike and what it looks like. The button with the spy looking guy and the spy hat is pressed by default. That means the desktop viewer is view only. Click that button again and you will be able to interact with the desktop. Use the different magnifying glass options to change the zoom level or size of the desktop as it's presented in your Cobalt Strike tab. Let's talk about post-exploitation tradecraft. Years ago, it was enough to get code execution, stay memory resident, and solve the comparatively hard problem of egress. Once you did these things, you were free to work on your objectives with little impunity. Today, it's not quite like that. Each action you take during post-exploitation may generate an observable event that is consumed by automated solutions or human analysts to try to detect your tools, your offense tactics, or even behavior that differs from normal. And any of these things can trigger an investigation into the endpoint you live on and begin the unraveling of your activity. For the purpose of this course, instrumentation and telemetry are the terms I'm using to cover a broad swath of security technologies and approaches to getting visibility into adversary behavior. Instrumentation are the techniques to give an analyst or security product visibility into endpoint activity. One approach for instrumentation is to use things baked into Windows. For example, ETW, event tracing for Windows, is an instrumentation technology baked into the Windows kernel. Another approach is to load a DLL into each userland process and hook the functions that a security product wants to have awareness of and veto power over when they're called. Telemetry are the events and properties of these events made available to an analyst or security product via these endpoint instrumentation techniques. Telemetry is what gets consumed by a security product trying to detect known bad, or by an analyst mining for or hunting for adversary activity. One example of a technology that generates telemetry is Sysmon. This is the System Monitor Agent. It is a driver, and it has the ability to fire several events that are consumed either within the Windows Event Viewer or off system via an event forwarding technology. And what's cool about Sysmon is it can load a config that states which events the analyst wants to opt into, what they want to see. And within those events, you can exclude things right away that you think are noisy, and you can include things that you explicitly want raised. One thing to note about Sysmon is that the documentation on the Microsoft page is very sparse. If you want an overview of which events Sysmon can generate and what the properties are of those events, I recommend that you go through the Sysmon config available via the Swift on Security GitHub account. This slide is a subset of Sysmon events and where they occur in Cobalt Strike. Here I also have a legend that represents Raphael's 5 minutes of thinking about it rubric on which of these events are very expensive for OPSEC purposes and which ones are not. You do not need to agree with my rubric, but as an offense operator, you do want to come up with a mental model that represents the risk versus reward trade-offs you will make when deciding which technique to use and if it's safe in your environment. And that's what I'm trying to encourage here. But let me explain why I have this rubric set up as I do. I have labeled process injection, Sysmon event 8, creating a thread in a remote process, as very expensive. It is very expensive because even though it's something the system can do, and there are legitimate projects that do this, it is something commonly seen in offense activity and something that is highly scrutinized when it occurs, meaning a detection strategy is just as well off isolating the few cases of known good and letting them through and considering everything else as bad. And that's why I label this as very expensive. What about process creates? Why do I label those as expensive? A process create is an expensive event because whether Sysmon is in use or not, every product, every defense strategy nearly is going to be looking at process creates, looking at arguments, looking at parents, and trying to decide, hey, is this sequence of process creates normal Is it normal system activity? And so that's something that can really stand out. Things I've labeled as somewhat expensive are things that are normal system activity, but can also be used as detection events when care is made to try to figure out what does the offense version of this event look like. For example, a network connection. I wrote a blog post a long time ago. Why is Notepad connecting to the internet? If Notepad is connecting to the internet, if you see sysmon event 3 from Notepad, that is weird. Same thing with Rundle32. I wrote a blog post later. Why is Rundle32 connecting to the internet? And that's an example of what I mean, where offense activity combined with this event can really stand out unless you're careful. And this is why in Lecture 3, Command and Control, I strongly advised that you try to match the type of beacon you have, for example, an HTTP beacon, to a process that normally loads WinINet, so that at least your event 3 activity, your network connection, is potentially plausible activity for that process. What about not expensive? I have certainly called out some things as being not expensive. A good example is event 5 process terminated. That is the kill command and beacon, but processes get terminated for all kinds of reasons. So I wouldn't consider that a major concern as a detection event. What about image loaded? The image loaded event is fired when a DLL is loaded into a process. I actually do think this is a very interesting event as a detection opportunity, but for different reasons, you may not see it used that way. For example, someone might choose to opt out of image loaded because they don't want the flood of data to mine through. And so they might not use it as a detection tool, even though it could be used that way. For example, Roberto Rodriguez, Cyber War Dog, has written some really awesome blog posts on detecting Mimikatz being loaded into a process by fingerprinting its DLLs. And here's that same table without the legend. The main thing I want you to understand is that the things you do in Cobalt Strike do generate telemetry, and that telemetry can be used to find your post-exploitation activity. The availability of telemetry is not detection, though. Detection is looking at an event and its properties in isolation, or a sequence of events and their properties to determine if some sort of offense activity is occurring. And this could be by looking for a specific technique, or by even looking for something that just stands out as odd. As an offense operator, you do want to know what defenders are looking for in their telemetry. One of the best sources of information on this subject is the MITRE ATT&CK matrix. ATT&CK is the Adversary Tactics, Techniques, and Common Knowledge matrix. It assigns a unique ID to each offense technique and groups each technique into a category, such as execution, persistence, privilege escalation, the different kinds of things you might try to do during post-exploitation. It is to your benefit as an offense operator to become aware of these things and how they map to the tools and automation that you use. Cobalt Strike can help with this. Cobalt Strike, when you use the tool, tags each post-exploitation action you take with a MITRE ATT&CK technique. And Cobalt Strike has the ability to give back a report that maps your different actions to these different tactics and techniques. And each mapping has a description of the tactic, a mitigation strategy, and detection methods. So standing up Cobalt Strike in a lab and just using the tool to mimic what you might do during post-exploitation to meet your objectives and generating this report is a great way to get situational awareness, either for yourself, if you're new to this tool set, or as a deliverable to your customer. Another resource that is really helpful to understand how different products consume the types of telemetry available and use those for detection is the MITRE ATT&CK evaluations. MITRE actually has the vendors pay them, and MITRE will go through and execute a scripted adversary simulation where they do different things a specific adversary was known to do, and they label whether or not the security product was able to detect it, see it in telemetry, and give you a lot of meta information just on how the product works. And there are screenshots within these evals as well, so you can learn a lot about how different products work by just looking at the attack evaluations. I really encourage you to go through them. I want to share some closing thoughts on instrumentation and telemetry. Let's start with this. Observable does not mean observed. Knowing how to see something in telemetry is a first step to a detection strategy. It is not a detection strategy by itself. False positive exceptions are a safe space for adversary activity. Further, a human analyst may not understand or properly action an event when it is observed. Closing the gap between observable and observed is a perfectly valid red team activity. Some people call it purple teaming. But helping an organization get a handle on this and close that gap is something that is part of what we do as offense professionals. Now, for organizations that are ready for a challenge beyond that, there are options to push back on this approach to defense. Broadly speaking, you can disable the instrumentation in some cases, and in other cases, you can spoof an event or event properties to fool instrumentation, or if there is something that is part of your attack chain that is so well detected, avoid it. More commonly, you will find that you need to understand the detections and adjust your operations to blend in with legitimate activity, or work within the false positive exceptions when they are known. Another option is to change your offense model. Some of my customers use Beacon as a pivot point only. It calls home and they tunnel tools on their network through it. They don't do anything else on the endpoint. Others will primarily live on Unix targets and go to Windows systems when they need to meet their objectives only. And still others will use an agent for a foothold or as little as possible, but rely on system administration tools and accomplish objectives without an agent as much as possible. I call this agentless post-exploitation. When you use Beacon for post-exploitation, here are the things I think you should worry about. In terms of behaviors, when you write a file to disk, execute a program, or inject into a new or existing process, these are events that can lead to your detection. For any of these events, or any other event, a common event property that you need to pay close attention to is your process context. This is both the origin of the event, where you're operating from, or the destination of the event. For example, if you inject into explorer.exe, that is a dangerous process context to inject into. If you inject into or interact with LSASS, that is dangerous. It is dangerous to operate from Notepad, PowerShell, Rundle32, or even servicehost.exe. I recommend that you avoid working from or operating on a commonly abused process context. Also, be aware that the events themselves are not always where a detection will occur. Sometimes an event is just a trigger for a point-in-time analysis. And a point-in-time analysis is a check where a product or tool will scrape the memory of a process and look for signs of memory injected content. So here, your post-exploitation tool, your memory injected DLL, can become a problem. Also, when you use PowerShell in .NET, there is a special case of instrumentation through something called AMSI and some of the behaviors in Cobalt Strike that I want to speak to on their own. One technique to make your process launches safer is session prepping. We talked about session prepping earlier in this lecture. One thing I hope you took from the demonstrations is that as an operator, you should always have awareness of your process context, your parent, and the process context that your child processes will launch in. That is very important. When I introduced session prepping, I promised to talk about block DLLs, and now is a good time to do that. In fact, I plan to use block DLLs as a case study in how to think about evasion. So let's start with this. One strategy to instrument an endpoint is to load a userland DLL into new processes, and from that DLL, hook functions associated with offense activities. This allows a product to watch for certain calls, analyze their arguments, and look for bad. There are several evasion options to push back on this instrumentation strategy. You can try to remove userland hooks and restore the original capability. You can try to load and execute your tooling before the hooking occurs. You can block the userland DLL from loading into the new process, or unload the userland DLL from the process. All of these things are possible in some situations. Here is how Cobalt Strike's block DLL start command works. It is a session prepping tool. It will have Cobalt Strike, or I should say its beacon payload, launch child processes with an extended startup attribute to deny non-Microsoft signed DLLs in the child process. This prevents the load of some userland DLLs into a child process that you launch. If that userland DLL is a security product and it's not Microsoft signed, this means your post-exploitation jobs, the things that run in the context of a temporary process, can run and do their activity without worrying about those hooks. I want to tie this back to what we talked about when I described the evasion process in general in the beginning of this course. I stated that you should know your tools and their behaviors, you should assess and understand the defenses, and combine that knowledge to decide the best option to use. I am a big believer that successful red teaming is all about judgment. So let's go through this. Block DLL start uses a startup attribute that is only available in Windows 10 from late 2017 and later. Said another way, this implementation does not work on Windows 7. The attribute does not block Microsoft signed DLLs. Microsoft signed does not mean Microsoft developed. There is a service where vendors can submit a DLL to be signed by Microsoft, particularly for hardware drivers. Block DLL start only impacts new processes run by that beacon session. It does not impact the current process. It does not impact executables generated by Cobalt Strike, HTA files, or anything else. Now, understanding that, let's talk about the defenses. Some products rely on userland hooks. Others do not. Since this feature was released in May, I have become aware of at least one product where the vendor went to Microsoft and said, "Hey, Microsoft, please sign our DLLs so we can load into processes when this attribute is present." I don't know if Cobalt Strike's block DLLs is what caused this, But I do know I had feedback in this particular case that, hey, this is working here. And hey, look, October, that DLL is now signed. As an offense operator, the lesson here is to know the options to push back on what you're doing and to keep an eye out for it. Offense and defense are constantly changing landscapes, and this assessing and understanding the defenses is something you have to constantly do. But when you're aware of the tool and you're aware of the defenses, you can decide when this option is a good option to use, and it can be very useful to you in those cases. I stated that process injection is a risky behavior in the Cobalt Strike product. You may have noticed with fork and run, Cobalt Strike does a lot of process injection. So, what can we do about that? Well, Cobalt Strike gives you control over how it does process injection via your malleable C2 profile. That is the process inject block. Here's what it looks like. The process inject block can shape the characteristics, behavior, and content when Beacon does process injection. For example, the allocator option allows you to choose between virtual alloc X or NT map view of section to allocate data in and copy data to a remote process. You can use minalloc and use RWX to change the characteristics of that memory in the remote process. Transform x86 and transform x64. These blocks can shape the content that is being injected into a remote process. And the execute block gives you a lot of control over how Beacon spawns a thread or otherwise passes execution to code that you copied to a remote process. And the way execute works is you specify what you want Beacon to try. And when Beacon has to do process injection, it will evaluate each option to see if it is plausible for the current context. And if it is, Beacon will try it. And if the option succeeds, it's done. And if it does not, Beacon goes on to the next option. Let's talk about that process inject execute block. There are 3 process inject situations, and your block should cover all of these. There is self-injection, fork and run, and remote injection into an existing process. You should order your execute block with your self-inject options first, fork and run options next, and then your remote injection options last. Your execute block needs to cover the trivial case of 32-bit to 32-bit or 64-bit to 64-bit. Those are trivial. What about 32-bit to 64-bit or 64-bit to 32-bit? What about going across desktop sessions? Some process injection techniques to run a thread or pass execution to code in a remote process work across desktop session boundaries. Others do not. Some functions are very visible. Create remote thread and RTL create user thread will fire sysmon event 8. Also be aware that a point-in-time analysis technique to find potential injection is to look for threads that have a start address that is not backed by a module on disk. You can avoid creating these kinds of threads by doing create remote thread, a module name, a function name, and an offset. And when you use create remote thread or create thread in this way, Beacon will create a thread in a suspended state, update it via set thread context to run what you want, and then resume that thread. And so that is a method to push back on this kind of point-in-time analysis. Ultimately, this slide is not a replacement for the documentation. If you want more detail on this aspect of customizing Cobalt Strike, I recommend you look at the malleable PE, malleable process injection, malleable post-exploitation documentation. In the interest of knowing your tools and where the tools do what, here is an overview of where Beacon does process injection. I have a legend here where I've color-coded each of these commands to the type of process injection. For example, green is fork and run. That is Beacon spawning a temporary process and injecting a capability into it. Fork and run is a favorable situation because we can take over the entire process and do things that might be a little bit more OPSEC friendly. Yellow are features that have fork and run variants and the ability to target a specific remote process. The yellow options are interesting because not only can you fork and run or go to an arbitrary remote process, you can self-inject with them by targeting your current process. And that is going to be the safest form of quote-unquote process injection. Pink is a feature that targets a remote process, and dark red is woe be on you, remote interaction with LSAS, which is very, very dangerous. For all these commands that do use process injection, it helps to know the alternative ways to achieve the same end. And you may ask, why? Why do we need to have alternatives? Why do we do process injection? Well, process injection is an evasion. It is a way to do offense activity and stay off of disk. Process injection is also a case where this fantastic evasion capability has also become a tell. And that is part of how defense keeps evolving. The things we use to hide become the things that are used to detect our presence. So if you are in an environment where you can't do process injection or certain forms of it, know these alternatives. Another concern when doing post-exploitation with Beacon are memory-injected DLL detections. We spoke to thread start address, memory permissions, and memory content as detection opportunities in part 4 of this course when we talked about weaponization. One item I didn't talk about then is behavior. When you have a memory-injected DLL or stager, it has to find the getProc address and load library function pointers. This is a detection opportunity. And this is a good opportunity to talk about a detection called export address filtering. And I'm using the Microsoft name for it, but the technique was not invented by Microsoft. I believe it was first described in a FRAC paper, and I'm absolutely certain other products use this same strategy or behavior, but for different reasons and do different things with the information. But let's explain the behavior first. Here we have a process, and within this process, we have our memory-injected DLL or our shellcode. Now, one of the first things our shellcode or memory-injected DLL have to do is they have to find the address of getProc address and load library. Because without this information, they cannot find the other parts of the Windows APIs to call them. No functions, no functionality. Okay, well, what does our shellcode do? Well, the information we want, for example, is in a DLL called kernel32. And this is mapped into the process space, but we don't know where. Specifically, a section of kernel32 called the export table happens to have this information. So how do we find kernel 32? What do we do? Well, there's another data structure called the PEB, and the PEB is available at a findable location. It is the process execution block. So to find kernel 32, what we do is we read the PEB, and we use the PEB to find kernel 32, and then we walk the export table looking for get proc address and load library. And we then have the pointers we need to start doing stuff. This is the behavior. Now, let's talk about the detection. And I think this is pretty cool. It's a really cool piece of detection engineering, if you will. One option is to set a hardware breakpoint on certain pages that might get read as part of this process. And what happens is when we read any of this memory, an interrupt gets fired. And that passes control to the security product that set the hardware breakpoint. And this is a chance to look at both the source of the read and the destination, and to use that information to determine what to do next. And that can be raise an alert. It can be deny the action or allow the action. At this point, what happens and which of these three options take place is dependent on the configuration of the system, the product, and what is doing it. But one opportunity for using this as a signal of process injection is to look at where the read came from and determine if it's a module backed by a file on disk or not. Is this just freely floating executable memory? Or is this from a memory mapped DLL? And if it is or isn't, that can determine whether you get a alert or a deny or an allow. And that is the export address filtering detection. So what do we do about these detections? The PostX block in your malleable C2 profile controls Cobalt Strike's post-exploitation DLLs. For the export address filtering detection that we just talked about, turn on Smart Inject by setting PostX Smart Inject to true. This is a really cool evasion. Earlier, you'll recall I stated that our memory injected DLL needs to find kernel 32 to find the get proc address and load library pointers, right? Well, here's a fun fact. The address of kernel 32 is random system to system, but it's not random in different processes on the same system. The address of kernel 32 only changes on reboot. So, if we know it in one process of the same architecture, we don't need to resolve get proc address and load library in other processes. And Smart Inject takes advantage of this detail. And what it does is it has Beacon propagate the get proc address and load library pointers to its child DLLs when they are of the same architecture. And so that's how Cobalt Strike pushes back on that type of detection. The thread start address and memory permissions of your post-exploitation DLLs are controlled by the process inject block in your malleable C2 profile. As far as memory content, set postx obfuscate to true. And this will enable some basic obfuscations of your post-exploitation DLL content. I want to talk about PowerShell and .NET evasion as a special topic. In this slide, I am speaking to PowerShell and .NET evasion for post-exploitation purposes in the Cobalt Strike product only. We are not talking about weaponization here. PowerShell and .NET are very attractive for post-exploitation for a number of reasons. First, there is an incredible library of open source capability written in PowerShell and .NET. Second, if you know how to meet your objectives with these capabilities, you can cross them between tool sets very easily, so you're not locked into Cobalt Strike or something else. Third, PowerShell and .NET are weaponizable in multiple ways. A good example is you can drop a .NET executable to disk. That's not the most OPSEC safe thing to do, but you can take the same program and pass it to a .NET Common Language runtime that you instantiated into a process and have that loaded into that CLR and executed without ever touching disk. And that's what I mean by multiple options to weaponize it. One thing that makes both of these technologies risky is AMSI. AMSI is the anti-malware scan interface. And AMSI is an opportunity for a program, in this case the .NET CLR or PowerShell, to pass data to an antivirus or endpoint security product installed and give them visibility into that thing being loaded regardless of whether it's touching disk or not. Cobalt Strike does have an option baked into PowerPick, psinject, and execute assembly to disable AMSI before it will load a script or executable. This feature is PostX AMSI disable in your malleable C2 profile, PostX being the PostX block. One thing I want to point out, AMSI disable mucks with the memory of the AMSI DLL. This is very dangerous, and it is subject to a cat and mouse game where I might muck with the AMSI DLL and Microsoft may come back and change some aspect of how that DLL works to break that blinding of this instrumentation. So be aware of that. For example, Cobalt Strike 3.14 is the latest version of the product. 4.0 is about to come out. 4.0 changes how PostX AMSI disable works, because between 3.14 and 4.0, an update to .NET and Windows broke what I was doing. And that's just to be expected. So be aware when you're doing this kind of evasion, it carries its own risks. The PowerShell command, be aware that that does use PowerShell.exe. You can use PowerPick or psinject instead. That's just fine. And I do want to talk about PowerShell import and how that works. PowerShell import, you'll recall, is a way to import a PowerShell script into your beacon and run commandlets from it. How does that work? Well, when you run a PowerShell script, Cobalt Strike will stand up a localhost only web server that hosts your PowerShell script that you imported. It will then prepend something called a download cradle to each command you run with PowerPick, psinject, or PowerShell. And that download cradle is something like new object, net web client, download string to get the script passed to invoke expression, IEX. Be aware this is a detection opportunity. You can customize this process by changing the download cradle and the shape of the PowerShell commands with the resource kit. So just be aware of that with regards to PowerShell import. In this lecture, we talked about beacon management. I took you through session passing and session prepping. We talked about different ways to execute a program and how to browse the file system of a compromised system and exfiltrate files. We also talked about how to take screenshots, and log keystrokes. When talking about tradecraft, we talked about instrumentation and telemetry and strategies to push back on both. I explained that writing a file to disk, executing a program, and process injection are events you should pay close attention to. And for executing a program and injecting into a remote or temporary process, we talked about strategies to push back on instrumentation and telemetry around those events. This concludes part 6 of Red Team Operations with Cobalt Strike, post-exploitation.